In this lecture, we are going to solve this problem called flood fill, and it's a very simple problem. We will be given a grid, and this grid, the different cells, they will represent a value that is the value of the pixel in an image. The image can be represented using a 2D grid, and each cell in this image represents the pixel value at that particular cell. So what is going to happen? We will be given a starting position, and from there we need to start updating all the pixels to a certain value. Okay, so we can only update those cells which are directly adjacent to the given starting point. Okay, so for example, we are given 1. From here we can move towards here 1. We can also move towards upside. Okay, and then recursively we can move to the neighbor of neighbors, right? So simply we can just perform DFS or BFS, whichever we like, and we have to just go through all these cells that have same value and update them to final pixel value, or you can say the numbers. They can not only represent a pixel, or we can also say that the number for the cell can also represent its color. So from the given starting point, we will be either moving directly horizontally or vertically to its neighbor that has the same value, and we will keep updating them to the given cell value as long as we are able to do that. For example, in the given example, we have a starting point of 1 comma 1. So this is our starting point, and the target color is 2. So we have to start DFS or BFS from here, and then we will uh, update all the values to 2 that has the same value as this starting point. So the starting point has value 1, so this also has value 1. This will also be updated, and similarly all of these recursively will be updated. For example, let's see, here we are starting at 1, so 1 is updated to 2. Then we will move to the neighbors which has value 1, and then we are going to also update it to 2. Then we are going to move to the next neighbor with the value 1. It is updated to 2. Similarly, the next neighbors, they will be updated to 2. Now from this cell we have nowhere to go, therefore we will backtrack. Okay, and then we will explore this other path where the current color is 1, and we have to update it to our target color, which is 2. Okay, so we will explore this path, and then this will be updated to 2, and finally we have nowhere to go, and all of these nodes, they are visited which had the initial color, and they are updated to our target color 2. Okay, so this is a really simple problem. We have to just pick a starting point which we are already given, and then we have to look for all the neighbors using DFS or BFS, and we have to see if the color for that particular pixel is the same as the starting point color. Okay, and we have to keep updating all of these to our target color. So let's go to Leetcode, and here we will solve the problem. So let me search for flood fill problem, and here I'll increase my screen size. Okay, so what we will be doing is basically, let's define rows and columns as the length of the image and length of the first row of the image. Okay, so we know the rows and the columns, and what we need to do is basically we will be giving a starting point, which is basically having the x coordinate as SR, meaning starting row, and SC, which will representing the starting column. Therefore, the start color is going to be the uh, image of SR SC. Okay, so this is going to be the start color, and our end color, which we want to paint, is given as the color variable. Okay, so what we need to do, we just have to perform DFS from this particular point. We will be giving the starting node as start. We will be given the starting node, which will be SR comma SC. This will be our starting node. Okay, and in order to perform the DFS, we will also need the image that is our grid in which we will be traversing. Okay, and we will also pass the start color and the end color. Okay, the start color is going to help us determine that which is the color that we want to update from, right? If the we will only update the grid cell if the value is equals to start color. So let's define our DFS method. Okay, so this will have the image. Okay, the node will be there, and what we will have the start color, the end color, and what, and then we will also have a visited uh, set, right? That is going to help us for DFS traversal. So what we are going to do, if not node means if the node is none, then we can simply return. Okay, and what else, if the node is out of the bounds, then we cannot do anything, right? When we are doing DFS, if we get out of bounds, if we are out of the image grid, then we won't be doing anything, right? So we will get the x and y coordinate for the given node, and then what we are going to do, we are going to check if x is greater than 0 or x is greater than equals to the length of image, or y is less than 0, or y is greater than equals to the length of image row, right? Sorry, image 0, which is basically the length of a row, meaning the length of the columns. So length of the row means total number of columns. So if this is the case, then also we are going to return. Okay, now what we are going to do, if we have already visited this node, then we are not going to do anything. Okay, so if node in visited, then we are going to return. Otherwise, what we are going to do, we are also going to check one thing. If visited is none, meaning we haven't provided the visited set, then we are going to set visited set to a new set. Okay, so this is just an error handling step. And now what we need to do, we have to also check if we want to update the current cell or not. We will update the current cell only if its value is equals to start color. So if the value of the current cell, image x y is the current cell, if this is not equals to the start color, then we will return. Okay, otherwise what we are going to do, we are going to visit the current cell, right? So we will add the x comma y current set to the given visited set array. This means we are marking the current position as visited. Then what we are going to do, we have a total of 4 different directions to go from here, right? Either left, right, top, or bottom. So what we are going to do is, before going anywhere, since we have visited the current node, one thing we are also going to do is the main point, that is updating the color for the current grid item or the current pixel to the end color, right? The end color, or you can say the target color, is the one that we want to update it to, right? And then what we are going to do, we are going to move into 4 different directions. So let's say D1, D2, D3, and D4. These are 4 different directions. Then what we are going to do, basically for these different directions, so we won't be storing the value, we will just be moving into them using the DFS call. So we will be calling self.dfs, right? And this will have all the arguments. Image will be there. The node, this time the node position will move to x minus 1 y. So this is the new position where we will be going, right? That is up position. And we will be passing the start color. We will be also passing the end color, and then the visited set will be passed as it is. Okay, so let's just copy this statement 3 more times for these different directions. So there will be a total of 4 directions. Okay, so now we also have to move down, right? So for that it will be x plus 1 and y, and for moving towards the left, it is going to be y minus 1 x, x and y minus 1 coordinate. And for moving towards right, it is going to be x comma y plus 1. So we are like this, we are going into 4 different directions after updating the current cell. And we are only doing this if the current cell is not equals to the if the current cell is equals to the start color. If it is not equals to start color, then we will just uh, return, right? Because we don't have to do anything else. So let me just run this code. It says so we are getting some error. None type is not a container or a iterable. Okay, so argument of type none is not if node in visited. So if node in visited, so at this point actually visited is coming out to be none, right? So we have to place this conditional statement before checking for a node. We have to first make sure that the visited set that we are searching in is actually not none, or we can make sure that it is none by explicitly passing the visited set. Okay, so here we are getting some sort of error, and that is because we are not returning the image. We also have to return the final image. Okay, so this is accepted. Let's just submit the solution. Okay, and our solution is successful. So let me once again walk you through the code. So firstly, what we are doing is basically when doing flood fill, we have to do the DFS, right? We are giving the starting position. The starting position will have the coordinate as SR, SC. SR is the X coordinate, SC is the Y coordinate. So image SR XC will represent the initial start color, right? We have to start from this one particular pixel that is represented by SR SC in the image, and then we have to uh, check that all the different pixels that adjacent pixels that we want to update should also have the same color, right? So we know the start color, and then the end color is basically given which we want to update it to. So we will start DFS from this SRSC coordinate, right, this pixel. And then in the DFS, what we are going to do, if there is no given node, then we have to just return. Then we will also take the x and y coordinate out of the given node, and then we are checking if it is out of bound. So when we are searching for the neighbor nodes, if we search outside the grid, then we will just return. Okay, and what we have to check for is we are making sure that the visited set, it is not none, okay, by this conditional statement. And if the node is visited, it is already visited, then we will just return, because when we are visiting a node, we are also updating its value. So if it is already visited, that means its value is already updated. Now we are checking that the current node on which we are, it has the same color as the start color or not. If it doesn't have the same as the start color, then we don't have to update it, right? So we are just returning. Now finally, after making sure all these checks they are passed, we have to now finally mark the current node as visited, and we are also updating its color. And then we are moving in all the 4 different directions, which are left, right, top, and bottom. So this was it. This was the complete solution for our problem, flood fill.